Hello, good morning, ma'am. My name is Alan. I'm from second year EC department. Today I'm going to give a presentation about the topic analysis of f of z that equals to 1 by z square minus 3z plus 2 in specified regions. Analysis of f of z that equals to 1 by z square minus 3z plus 2 in specified regions. Solving for mod z minus 1 which lies between 0 and 1 and mod z which lies between 1 and 2. And here is the problem statement, that is, state the function f of z equals to 1 by z square minus 3z plus 2 in the region of interest mod z minus 1 which lies between 0 and 1 and mod z which lies between 1 and 2. Factorizing the denominator, let's factorize the denominator. Factorize z square minus 3z plus 2 into z square minus 3z plus 2, that equals to z minus 1 into z minus 2. Let's rewrite the function as f of z equals to 1 by z minus 1 into z minus 2. Partial fraction decomposition. Let's use the partial fractions. F of z equals to a by z minus 1 plus b by z minus 2. Solving for a and b, we get a as 1 and b as minus 1. And final decomposition, f of z equals to 1 by z minus 1 minus 1 by z minus 2. And the region 1, 0 less than mod z minus 1 less than 1. Explanation of the region. Mod z minus 1 measures the distance from z to 1, and 0 less than mod z minus 1 less than 1 implies z is near 1 but is not equal to it. Series expansion. Series expansion for 1 by z minus 2. In the region 0 less than mod z minus 1 less than 1, mod z minus 1 is less than mod z minus 2. Expand 1 by z minus 2 as geometric series. 1 by z minus 2 equals to minus 1 by 1 minus of minus z minus 1, and 1 by, which gives 1 by z minus 2 equals to minus summation of z minus 1 power n. Series for f of z in the region 0 less than mod z minus 1 less than 1. Substitute into f of z, that equals to 1 by z minus 1 minus 1 by z minus 2. That gives f of z equals to 1 by z minus 1 plus summation of z minus 1 whole power n. Region, coming to the region 2, 1 minus z. Coming to the region 2, 1 is less than mod z less than 2. Explanation of the region. Mod z measures the distance from z to the origin. 1 is less than mod z less than 2 implies z is between the circles of radius 1 and 2. Series expansion for 1 by z minus 1. In the region 1 less than mod z less than 2, mod z minus 1 less than mod z. Expand 1 by z minus 1 as Lorentz series. 1 by z minus 1, that equals to 1 by z into 1 by 1 minus 1 by z, which gives 1 by z minus 1 equals to summation of 1 by z power n. Series expansion for 1 by z minus 2. Similarly, expand 1 by z minus 2, which gives 1 by z minus 2 equals to 1 by z into 1 by 1 minus 2 by z, which gives us the equation 1 by z minus 2 equals to summation of 2 power n by z power n. Series for f of z in the region 1 less than mod z less than 2. Let's combine the expansions. F of z equals to summation 1 by z power n minus summation 2 power n by z power n. That gives us f of z equals to summation of 1 minus 2 power n by z power n. Comparison of regions. Show the differences in the series expansion for the two regions. Coming to the region 1, centered around z equals to 1, the series expansion converges for 0 less than mod z minus 1 less than 1, and For the region 2, it's centered at the infinity Lorentz series. The Lorentz series converges for 1 less than mod z less than 2. The graphical representation: visualize the two regions on the complex plane. Region 1, annular region around z equals to 1, and for region 2, annular region centered at z equals to 0. Convergence of series. For region 1, the series converges when mod z minus 1 is less than mod z minus 2. The convergence relies on z minus 1 is less than 1. And for region 2, the Lorentz series converges for 1 less than mod z less than 1 less than 2. Convergence is based on the relative magnitude of mod z to 1 and 2. Applications of series expansions. They are used in solving differential equations and analyzing complex functions. And general formula recap. Here are the formulas for region 1 and region 2. Error analysis. Errors in truncating series. Approximation errors arise from limiting the number of terms in the expansion. Increasing terms reduces the error but requires more computation. Errors reduce techniques. Use computational tools for higher precision. And challenges in analysis. Difficulties in performing series expansion manually. Importance of computational tools. Conclusion. So, we explored the function f of z into two regions and derived and analyzed the series expansions, and that's it. Thank you.